Hi everyone, today we're doing notes on 3.7, arguments and truth tables. So an argument consists of two parts, the given statements called the premises and a conclusion. An argument is valid if the conclusion is true whenever the premises are assumed to be true. A valid argument with true premises is called a sound argument. An argument that is not valid is said to be an invalid argument, also called a fallacy. So here's a table that talks about testing the validity of an argument with a truth table. So you're going to use a letter to represent each simple statement in the argument, express the premises and the conclusion symbolically, write a symbolic conditional statement of this form. So to simplify this for you, what this will look like is basically you'll have one premise A and another premise B. So you're going to say if A and B, then C, which is your conclusion. We construct a truth table, and then in the final column of the truth table, if it's a tautology, then the argument is valid. All right, so here we're going to use the truth table to determine whether the following argument is valid or invalid. The United States must energetically support the development of solar-powered cars or suffer increasing atmospheric pollution. So that's P or Q. Then it says the United States must not suffer increasing atmospheric pollution. That's not Q. Therefore, the United States must energetically support the development of solar-powered cars. So that is P. Anytime you see this word therefore you express as three little dots. That's how you're writing therefore in symbols. And so basically, when we're going to be determining if this is valid or invalid, like we said, you have to combine A and B with and. So we're going to use and to combine these. Then C, or our conclusion. Okay, so let's fill out our truth table. We know we're going to need the negation of Q. So that's false, true, false, true. We need P or Q. So that's going to be true, 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 false. Okay, so now we're going to do the first part. We're combining our two premises with and. So we have P or Q, negation of Q. And again, we're going to combine these with and. Okay, so P or Q and not Q. I have true and false, which is false. True and true, which is true. True and false, which is false. False and true, which is false. So now the last step is we have to see if this whole thing we just did, if P or Q and not Q, then P. So if P or Q and not Q, then P. So we're going if P or Q and not Q, then P. So take a minute and evaluate this last step of the truth table. Okay, so in this case, I have if false then true, which is true. If true then true is true. False then false is true. False then false is true. So this is a tautology, which means our argument is valid. All right, let's go to the next one. This says, I study for 5 hours or I fail. I did not study for 5 hours, therefore I failed. So again, we have I study for 5 hours or I fail. This is P or Q. I did not study for 5 hours. This is negation of P. Therefore, I failed, which is Q. So again, we have to combine these with and then do if then to our Q. So let's start with the negation of P. So that's false, false, true, true. Then we have P or Q, which is true, 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 false. Now we're combining our two premises with and. P or Q, not P. We're combining with and. So here we have, this will be false, false, true, false. And now our last step, we're going to be doing the whole thing. So if P or Q and not P, so if P or Q and not P, then Q. So the column we just did, then Q. So take a minute and fill this one out, please. Okay, so we have if false then true is true. If false then false is true. If true then true is true. And if false then false is true. So again, this is a tautology, so this is another valid argument. Okay, this next one, we're going to have 3 statements. If you lower the fat in your diet, you lower your cholesterol. So this is if P, then Q. If you lower your cholesterol, you reduce the risk of heart disease. So this is if Q, then R. Therefore, if you do not lower the fat in your diet, you do not reduce the risk of heart disease. So this is negation of P, then negation of R. And so again, we're going to be combining these with and then doing the conditional statement. So we have some negations here. We have negation of P. We also have negation of R. So let's fill those in real quick. Okay, so let's do our simple statements. So we have if P then Q. So again, for if then statements, it's only false if you have if true then false. So that means these two, the third case and the fourth case, are false. So the rest are true. We also have if Q then R. And again, same rule for if then statements. So if true then false, so the second case is false. And then the third one up from the bottom, or the sixth case, is false. Everything else is true. So now we need to combine these two with and. So we have if P then Q, if Q then R, and again we're combining these with and. So we have true and true. This is true. Remember, anytime we see a false, it's false. So this one's false, false, false. We have another true here, and then false, and then true, and true. Okay, now to make things easier, I'm going to call this statement A, just to save us a little space in our truth table. We also need this conclusion. If not P, then not R. So I'm going to do this one. Negation of P, then negation of R. And so if not P, then not R. So again, this is an if-then statement. So the only time it's false is if you have if true, then false. So that's going to be this case, the fifth case, and the seventh case. Everything else is true. I'm going to call this conclusion B. And so then to save us a little space, I'm going to write this last column in our truth table as if A, then B. So take a minute and fill this one out to determine if our argument is valid or invalid, please. Again, anytime we have if true then false is the only time that our conditional statement is false. So we have this case right here, the fifth case, and the seventh case are false. Everything else is true. But we do not have a tautology in this case. So in this case, this argument is invalid. Okay. We have this table here that talks about different types of reasoning: direct, contrapositive, disjunctive, transitive, fallacy of the converse, fallacy of the inverse, misuse of disjunctive reasoning, and misuse of transitive reasoning. If you notice the top, these are all the valid arguments, and the bottom row is all the invalid arguments. You will be given this table. You do not have to memorize this. We just have to know how to use it. So let's look at number 4 here. It says determine whether each argument is valid or invalid. The emergence of democracy is a cause for hope, or environmental problems will overshadow any promise of a bright future. Environmental problems will not overshadow any promise of a bright future. Therefore, the emergence of democracy is a cause for hope. So this one's very wordy, but it's not too bad to break it down. So our first statement says the emergence of democracy is a cause for hope, or environmental problems will overshadow any promise of a bright future. So this is P or Q. Then it says environmental problems will not overshadow any promise of a bright future. So this is negation of Q. Therefore, the emergence of democracy is a cause for hope, P. So if I look at my table above, this argument matches the disjunctive reasoning, right? If I look, it's this one, P or Q, then, P or Q and not Q, then P. So we can say this is a valid argument because of disjunctive reasoning. Okay. Our next one says, if the defendant's DNA is found at the crime scene, then we can have him stand trial. He is standing trial. Consequently, we found evidence of DNA at the crime scene. So if the defendant's DNA is found at the crime scene, then we can have him stand trial. If P, then Q. He is standing trial is Q. Consequently is another word for therefore. We found evidence of his DNA at the crime scene. P. So I want you to take a look above and tell me if you think this argument is valid or invalid, and tell me why. So this argument is invalid, and this is because of the fallacy of the converse. All right, this last one, I noticed there's a small typo. This should be a period, not a comma. Sorry for that. I want you to look at C. I want you to write out the argument on your own and determine whether it's a valid or invalid argument. Okay, so if you mess up, your self-esteem goes down. This is if P, then Q. If your self-esteem goes down, everything else falls apart. This is if Q, then R. So, again, is another word for therefore or consequently. If you mess up, everything else falls apart. If P, then R. And this one ends up being a valid argument. And this is because of transitive reasoning. Okay, let's keep going. This is another one where we're determining whether the following argument is valid or invalid. So it says, if people are good, laws are not needed to prevent wrongdoing. So this one is if P, then not Q. If people are not good, laws will not succeed in preventing wrongdoing. So this is negation of P, then negation of R. Therefore, laws are not needed to prevent wrongdoing, or laws will not succeed in preventing wrongdoing. This is negation of Q or negation of R. Now, to save us a little space, I'm going to list all of the negations just inside or underneath the P, Q, and R if you need them. So I'm going to just write these tiny in here. At this point in our unit, if you don't need to write these negations, that's okay. You don't need to write them out if you can just do that part in your head. Okay, so our first statement we have is if P, then not Q. So again, for if then, the only time it's false is if you have if true, then false, which happens to be these first two cases. Then everything else is true. Our next statement we have is if not P, then not R. Again, same rule. And so the only two cases where we have if true, then false are the fifth one and the seventh one. Everything else will be true. So now we have to combine these with and. So we have if P, then not Q. If not P, then not R. And again, we're combining these with and here. So for and, remember they have to both be true in order to be true. So our third and fourth cases are true, as well as our sixth and eighth. The other four are false. Okay, next we need to do our conclusion statement. So negation of Q or negation of R. When we're looking at or, remember it's only false if they're both false. So that's going to be this first case. And then the next one is the fifth case. All the rest are true. And last, we need to put this all together for our argument. So I'm going to call this part A, our conclusion B. And so if we have if A, then B, I want you to fill this in to determine whether our argument is valid or not. Okay, so for this one, we have true, 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 true. So this is a tautology, so this is a valid argument. So we can say here a logical or valid conclusion is one that forms a valid argument when it follows a given set of premises. So now we have to draw a valid conclusion from the following premises. If all people lead, then no people follow. Some people follow. So we have to be careful. We have some quantifiers here, all, no, and some. Okay, so it says if all people lead, then no people follow. So if P, then Q. Then it says some people follow. If you recall, the negation of none is some. So this is actually negation of Q. Therefore, now we have to draw a valid conclusion from the premises. So if we look back at our chart, we can actually use contrapositive reasoning to help us conclude negation of P. So our conclusion would be, therefore, some people do not lead. Again, we're doing the negation of P. Negation of all is some do not. So we're going to conclude that some people do not lead. All right, let's do B. If all students get requirements out of the way early, then no students take required courses in their last semester. Some students take required courses in their last semester. So again, here we have all, a no, and a some quantifiers. So let's write this out symbolically. If all students get requirements out of the way early, then no students take required courses in their last semester. So if P then Q, then some students take required courses in their last semester. So this is negation of Q. Therefore, now this is the same argument as what we just did. So again, we can use contrapositive reasoning to conclude negation of P. And so I want you to write out the conclusion here. Take a minute and please do so. All right, so in this case, we can conclude some students do not get requirements out of the way early. And that's all we have for today.